Okay, this is Mrs. Davis again. We're still on lesson 111. This is the third video, and we're starting with example 4. We're kind of going to go backwards now and try a different way of thinking. The graph is given, and we want to try to write the equation in factored form for it. And so we're going to use the things that we see on the graph to help us. We should see anyway, that we have a hole right here. We have a vertical asymptote at x equals 2 and a horizontal asymptote at y equals -1. So that tells us quite a few things. It first tells us that, that we have a hole at 2, meaning, or 1, 2, 3, 4, at 4, we must have an x minus 4 on the top of our graph. Let's put f of x equals. And 1 on the bottom. They would cross out and they would give you the hole. Now we also have left over a vertical asymptote at 2, so we have to have x minus 2 in the denominator. Okay, now we also have a 0 at, we didn't talk about this, at 3. So there's your 0. This is your hole. That's your vertical asymptote, and that's your horizontal. So we have a 0 at 3, so that means we must have x minus 3 in the numerator. Now the only thing that's left is our horizontal asymptote, and it has to be -1. So if I were to multiply these two things out, they would be x squared on the top and x squared on the bottom, dot, 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 dot. And that would be y equals 1, but we want y equals -1, so there has to be a negative sitting out in front. So we'll put a negative there, and that's our solution. Pretty cool. We can write the whole function in factored form from the graph. You could multiply it out to get it in general form, but that would just be a waste of time. We just need it in factored form right now. So let's do this one. If you want to stop the video and try to do this one on your own, but come back and we'll check it out. All right, so the first thing we see is that we have a vertical asymptote here. Okay, and we have a hole. We have a hole here. We have a 0 here. And it looks like we also have a horizontal asymptote at y equals 0. So let's get started. It doesn't show the dotted line, but this also looks like it is a vertical asymptote. So all right, let's do the hole first. I always start with that. So this is a g of x function, so g of x would be equal to, the hole is at 2, so x minus 2 over x minus 2. We then have vertical asymptotes at x equals 0, so we would have an x, I'll put it out in front, and at 3, so I have to have an x minus 3. All right, and now I'm going to look at my 0. I had a 0 at 1, so that means x minus 1 must be here. And let's see what we get. When we multiply this out, if we were going to put it in standard form, I would get x squared on the top, and on the bottom, I would get x cubed. And so because of our rule, the degree on the bottom is 1 greater than the degree on the top. We have a horizontal asymptote at y equals 0, which is what we have here. So we don't have anything to change. So that would be your answer. All right, let's look at, we're going to kind of switch a little bit. And we're going to talk about something here, slant asymptotes. And I don't know whether you've talked about these before or not, but it just means that you don't always have you don't always have horizontal asymptotes. You could have none, or you could have a horizontal, or you could have a slant. This is an example of the graph that has a slant asymptote. And we should also write in that it has a vertical asymptote here, and it looks like a vertical asymptote at -1. Okay, and so you can see the graph is following those asymptotes and the slanted asymptote. So in this one, it comes down and follows that one, and it follows that one, and then this is going to follow this slanted asymptote till it gets to the vertical asymptote. Now, how do we know if something has a vertical asymptote? A slant asymptote. And it's because when you have the degree of the numerator one degree higher than the degree of the denominator. So we have an x cubed over an x squared, so this would have a slant asymptote. Now, in order to graph, you want the equation of that asymptote. Now, it's going to be a line, because if you have 1 degree greater and you have an x cubed over an x squared, if you divide those out, it's going to be an x. So it's going to be a linear line. So it's going to be a y equals something. Now, in order to find those, we need to try to review a little something about long division and synthetic division. Because how you figure out what the slant asymptote is you rewrite the function as a divided polynomial, or a divided rational function into a polynomial with a remainder. Okay, but we have to review how to do this. So there's 2 ways: long division, which always works, and synthetic division, which works if you have a very easy denominator. And so we're going to do both ways to review. So this is totally review, hopefully. And you need to practice. You'll be doing this a lot if you don't know it already. All right, so we have long division. You just write it out like a long division math problem. I'm dividing by x minus 3, and what I'm dividing is x squared minus x plus 2. Now, you're verifying as you go that you have each term, because if you were missing a term, you would just put a 0x or a 0x squared. But we have every term. We have the square term, the linear term, and we have a constant, so we're good. Now, we say to ourselves, what value of x, what times x will give me x squared? And the answer would be x. So then I multiply these 2 things out, and I get x squared minus 3x. So you draw the line here. We're going to subtract. Now, I always put this in parentheses and put the subtraction out here so that I remember. So x squared minus x squared is going to be 0. I have a negative x minus a negative 3x, which would change to a positive 3x. So this ends up being a positive 2x plus 2. All right, and now I'm looking at this x and that to see what times x gives me a 2x. And so it would be a 2, and it's a positive 2, so I put plus 2. And if we continue on, we get 2x minus 6, which gives us negative 2 plus 6, so it's going to give us a remainder of 8. So I'm just going to put R8 like in the old days. Now, what you found is that this can be written as the answer as x plus 2 plus 8 over x minus 3. Okay, and so that's how you would divide that long division. Now, guess what? This part without the remainder is your slant asymptote. So y equals x plus 2 would be our slant asymptote. Okay? Now, in this case, this is definitely a candidate for synthetic division because it has a very simple denominator. So if you remember synthetic division, it's always the actual 0 that you put in the box. So you would put a 3 here because x minus 3, the 0 is 3. All right, and then you take the coefficients off the numerator. So it would be 1, -1, and 2. You leave a space and draw a line because you're going to put things in this row. Now remember, you always bring the first number down 1. Now then that number is multiplied by 3 and written here, so that would be 1 times 3 is 3. And then you add. So -1 plus 3 is 2. And now I multiply again. That would give me plus 6, and I get 8. Now, hopefully you remember in synthetic division that this is your remainder. The last term would be your remainder. It could be 0, and that would mean it goes in evenly. And this is called the depressed, D-E-P-R-E-S-S, depressed polynomial. And so it's just one term less. It was an x squared, so it becomes 1x plus 2. So 1x plus 2. So x plus 2, remainder 8, and we got the same thing. So y equals x plus 2 is our slant asymptote. Now, you don't have to find the remainder the minute you find the part that's not the remainder. You can go ahead and write your your slant asymptote equation. All right, I'm going to stop this video there.